It's very exciting to be here, and this is a fabulous project, and it's been a real team effort, and I'm very excited to be talking about how we've been going to date and sharing the load with Daniel, who will talk later on. So a lot of people might make the assumption, I suppose, that the bushland areas, the amazing bushland areas that are left in central Victoria are, natural and intact. In many respects they are, but in many respects they're also quite degraded and modified. There's been all sorts of disturbances and threats introduced post-European arrival, stock grazing, species extinction, the removal of Aboriginal traditional practices, timber harvesting, weed invasion and so on. So things aren't necessarily all as they seem, and quite a few years ago there was a study done looking at sort of old growth bushland in this region, and they did fairly detailed work, and if you just focus in on the statistic on the right, the largely intact landscape, what's next to that? It says nil. So they didn't find anywhere that they thought was not disturbed or modified, and the gold fields and the gold rushes have been incredibly destructive in terms of the impact that they've caused. And this is what the bush looks like in many areas today. It's by no means what everything looks like, but it's pretty common. Very sort of multi-stemmed, small stems, and depauperate understory. So multiple stem coppice, very little woody debris on the ground, closed canopy, slow growth rates, immature trees, few hollows, limited flowering, often depleted soils and ground cover, and hydrophobic, limited nutrient cycling, and leaky. And leaky landscapes is the key to this project in many respects, which I'll go into. So you may know that there are still, fortunately, some areas that have been perhaps less impacted, and it's a good idea to sort of tune into where they are. I call them living benchmarks. So these are the best remaining areas, and there's still a few pockets around here and there, and they give you a bit of an idea of what the understory in particular used to look like. That's one example near Tubarak, and this one's over near St Arnaud. And it's a bit of a shock sometimes to realise that the bush should be looking like that in the ground, not like that previous shot. So a lot of the catchments, because of this degradation and the gullying that's often widespread, when it rains, the rain just flows straight out of the system and doesn't get used up by the local biota. And it's what we call leaky landscapes. And you can see the green there in the system, and it sort of looks like everything's growing and it's lush. But it turns out, if you, just a month or so later, that it all just dries out quickly, because that's annual grasses which have been invaded because of the disturbance. So this is a project about integrated landscape restoration, desertification, and it's something that can be exacerbated by climate change, and it's based on three principles or sort of historic lines of practice. Landscape function analysis, some of you might have heard of, which was developed in rangeland areas, and it's been really sort of instrumental in that context, mainly around soil surface condition. Forest silviculture, which has long been practiced in the area, but there's some really good understandings there about how growth rates can be manipulated. And then habitat manipulation trials by Parks Victoria, who set up some trials, some really sophisticated trials about 15, 20 years ago, which are fantastic, one of which is just down the road from the site in near Heathcote. So landscape function, just quickly, is really about looking at stability, surface soil stability, infiltration of moisture, and nutrient recycling. And this is a picture of a tractor that's with a keyline type system that's been adapted from tree planting use in agricultural contexts. So rather than using it to improve degraded soils in paddocks, we're looking to adapt it for a degraded woodland or forest situation. So ecological thinning is another one. Increases coarse woody debris, increases growth rates of residual trees, and it can lead to an increase in understory cover, which we'll talk about later, and also habitat and landscape function benefits like water infiltration, soil and productivity. So this is the site. It's just south of Heathcote on the Mackay catchment, and there's a series of micro catchments that go up into the local bush there, which is now called Spring Plains, or a lot of it's called Spring Plains NCR. Populations of some threatened animals like brush-tailed phascogale and swift parrot was a particular hotspot in this area. You can see the records there in the past. So the idea was to sort of choose a site that would potentially have benefits for these sort of threatened species, and not just take it for granted that because they're there, they'll always be there, and that if we don't do something, we might lose them. So we chose the area in blue, which is called Peters Gully. The area across the reserve is about 150 hectares, and then a gully next door called White's Gully, which is very similar, and where we're not going to treat it as a contrast. So we did a few things. We did ponding in the valley bottom, got a little small machine and a very friendly and cooperative machine operator, and we built some little ponds, which were quite small and just using regrowth. It was very low cost, very low tech, but we think it's been quite effective. They basically hold up small amounts of water up and down the valley, and then they sort of leaky. They're kind of leaky weirs, I guess it's based on that sort of idea. And then this is a bit of a video that Cam took. If you'll just find the... oh, there we go. So you can see it after a decent sort of downpour there, and you can see the tussocks that they've been planted. So things like rushes and sedges and some stuff like the tall poas have been planted in there to try and provide stability with that over time. So the idea is to produce a succession of these ponds up and down the valley bottom. And then another one we did was ripping, like I mentioned before, the keyline work. Now, this is a time lapse of Cam doing the work. He's a very fast worker. We did over 70 kilometres in this little catchment, which is quite remarkable, just weaving up and down on the contour. And the idea is to produce a sort of furrow along the contour that provides a barrier to soil runoff, and it just goes into the subsoil rather than running off. This is what it looks like afterwards. Just going back on the previous presentation, in some respects it mimics that sort of ecosystem engineering digging that used to be present in the landscape and these days is more or less absent. That's part of the motivation. We also did ecological thinning, which Daniel will talk about later. Here's a video that Cam took again, just showing the results so far. It's a bit of a time-lapse contrast. So this is before the treatment, and then straight after it, you can see the opening up of the canopy, a bit of woody green on the ground, and then the understory actually does look like it may have palpably improved, but we'll talk about that in a minute. Move on. And we also put wallaby grass seeds along the furrows. So wallaby grasses are quite common in this landscape. They're easy to collect and they're easy to grow from seed. So we just got a lot of wallaby grass and just manually scattered them with volunteers, which is great. And so I like to think about this as a food web, where we've got a cascade of influences running from the sort of the base processes like soil development and hydrology and so on, up through primary production to the higher order predators. And our monitoring program is designed to look at various aspects in that hierarchy. So in terms of the results, it's very hard to measure hydrology in ephemeral streams like this. Flashy flows are the characteristic, and after an event of 60 mils in October last year, this is after the treatment, in the untreated catchment, this is what it looked like at the bottom, where you've got clear sign of flow just in that last 24 hours. The leaves have been pushed aside and you can see moisture in the paddock in the background. Whereas the Peters Gully, the one we treated, at the same position in the landscape, you can see there's no flashy flows at the bottom. So the presumption is that a lot of the moisture that fell in that event went into the ground and not down out into the paddock next door. That's anecdotal. We're working on a more robust framework for measuring hydrology, but certainly the positive signs are there that literally within hours or days of doing that work, you can get these hydrological benefits. We also monitor the grazing pressure, which we've talked about today, mainly just to keep an eye on it because we know that grazing pressure can be a problem with restoration, and it's more just to keeping an eye on it. But some of the results that Cam's given me here, you can see that the curves show the exclosure, which are small little fences, and then controls of the non-fenced areas. So over time, the control areas did uptick a bit because of higher rainfall, but the exclosure was much higher again. So, and the latest data that Cam gave me showed that there was actually a difference between the treated catchment and the non-treated. I think about 5% increase in cover as a result of the treatment. So that's promising. I'm going to be collecting some more precise data in that space later in the year, so hopefully I'll be able to come back with you some more definitive data very soon. Invertebrates, so a lot of our work done there. Invertebrate work, there's been an increase in invertebrate species in the treated area, and that's largely due to groups like aquatics, due to the increase in moisture. And with gliders, there's been a lot of nest boxes have flooded the area, I think hundreds of nest boxes, and as a result, these arboreal mammals and phascogales as well have occupied them, and that's been a clear response because of lack of hollows, but in the long term, we're hoping that the effects of increased productivity in the system will also boost populations, but that's to be determined. I might actually skip over that. We don't need to. So what's next? Knowledge sharing. We're already doing some work in that space. We're doing citizen science events, media production, and we're also wanting to partner with other organisations to develop similar sort of projects along these lines. And we want to expand our interventions, rewilding the understory, planting missing threatened species and keynote species, and more ponds, and there's other things we can do. And the indicators for monitoring are happening over 10 years. That's our commitment, and developing partnerships to monitor hydrology. So we've got a volunteer citizen science program, so that's the QR code for that. If you look on our website too, and future donations for the continuing the project is another thing we need support with. So I want to thank all our supporters, and I'm going to hand over to Daniel now. We've a lot of people that have helped out with all sorts of aspects, and we really appreciate their input. It's been a fantastic support. It wouldn't be possible without you, and we hope we can continue to work with you in the future. So Daniel's going to talk about the operational aspects of the thinning. So fire away. Just go to the next slide.
Okay, thank you, Paul. Thank you to Biolinks for inviting me to speak. This is a topic that is really close to my heart, and it's awesome to be able to come and talk about what we did and how we did it, and field a few questions, because there's always some questions when we're dealing with this kind of I guess a little bit controversial type of work that maybe doesn't immediately seem like a good idea. Maybe we think about cutting down trees as not necessarily focusing on conservation, but hopefully we can run through some points today. I can talk you into it a little bit. I'd like to acknowledge the traditional owners where we're meeting today, the Jara, and traditional owners more broadly. We work right across Victoria, so it's a little bit inappropriate for me to be specific with my acknowledgements. We cover all countries. And just a little bit of a background, we've, as an organisation, got a fair bit of experience with eucalypt thinning. Quite broadly, we've done a lot of red gum thinning in the past, but this is the first time we've really moved up into some of these drier central Victorian forests. It was a great opportunity to get involved. We'll tell you a little bit about it. Firstly, probably quite importantly, as Paul touched on, a lot of the work that Parks Victoria have done and other researchers have looked at in the past, there's a bit of a scientific underpinning to what we're doing. We're not just assuming that maybe it's going to work and having a crack at it. There's actually a scientific basis to our work, and the experimental work that's gone into this has been quite elaborate. And that Parks Victoria research that was done is very comprehensive. That's an enormous document. If anyone wants to look it up and read it, it's very thorough. They assessed everything. It was a really, really good body of work. And the basic theory that underpins what we do, or why we're attempting to do what we do, is that a lot of these forests over the course of the gold rush and the last 180 years, they've been disturbed, they've been cleared, and what that does is it then synchronises them back, and you end up with some even age class forests. And you saw some of the photos that Paul put up earlier. You can sort of see that. You've got these forests where all the trees are the same size, and there are some areas where you do retain some large trees, and those areas are really quite disproportionately significant in these landscapes. There's not a lot of them left. We really need to sort of get some of these forests out of the stasis that they find themselves in. The natural processes that would have driven these thinning events historically, we don't really fully understand, and we think it was probably just the low productivity landscapes will have been just naturally quite slow to thin. But that's not necessarily helpful when we're dealing with threatened species conservation, and we can't really wait 300 years for a forest to naturally achieve a climax state. We sort of, when we've got these isolated reserves in matrices of farmland and whatnot, you're kind of obliged to give them a little bit of a help along. That's sort of what we're attempting to do. The very first thing I need to mention before we go any further is, before you go and buy a chainsaw and start getting into it, yes, you do need a permit under clause 5217 of the planning scheme to remove native vegetation. You can get an exemption. You still need to go through the process. I think that's just something that I'd like to flag up front that, it doesn't matter how much you get on board, you still need to go through the process and think about some of the regulatory framework around what you're doing. Why would we consider thinning? I've already sort of touched on this a little bit, but a lot of these woodlands and forests that have been historically cleared, they just sort of get to an age where they stop growing. They just sort of find a tree density that they're relatively happy with, and that's where they stay. And that's a real problem when we're trying to encourage large trees that, disproportionately support threatened species or all species, but they disproportionately have, tree hollows for habitat and extra nectar reserves and all of these benefits that come from large trees. That's sort of what we're trying to push the forest towards a state where it has more of these values and less of this sort of homogenous, reasonably young forest. Even though it's not young, it just hasn't really developed those attributes that you get with older forests. It sort of ties in with the broader Spring Plains project. Some of those natural hydrological features that you get to, like large densities of small trees, they'll suck up more water. There's not a lot of room for the water to fall on the ground and infiltrate. Like they tend to be quite drier landscapes as well when you've got those really, really dense stands. In terms of how we think about what we're going to do when we walk into a forest, I've sort of got a few, just a couple of slides that are basically just text that we'll just sort of work through. A lot of these dot points probably warrant a couple of slides on their own. So I fully expect there'll be some questions about some of these specifics. Find me afterwards, we've got a few minutes for questions, but I'm more than happy to talk about any of these things that you think need fleshing out a little bit. So the way we tend to approach it in the first instance is just to find the trees that you think are eventually going to assume dominance and just start protecting those, start buffering those. And you'll often have a reasonable sized tree with smaller trees underneath it that are already senescing and already dying. So they're the obvious first choice when you want to start doing some thinning work. These little trees that are already shaded by an overstory, they're the first ones that can go. And then we tend to start looking at trees with structural and health defects. So if you think about it from a picking winners perspective, and we're speeding up that natural process, so that process that would have happened anyway where the strong trees assume dominance and then grow old, we're just speeding that process up. So the trees that probably won't make it to old age anyway are the ones that we prioritise taking out. And there's a list there, trees with the bifurcated, trees with co-dominant leaders, damaged trees with wounds, any sort of, things that are structurally unsound, like branches derived from epicorms, and then trees that are just naturally looking quite unhealthy. You might suggest that bracket fungi is a sign of rot or something, that's a bit of a controversial one. And then once you've done all that, you end up with the unfortunate situation of you need to take out some good trees. So every now and then you get to the point where there's some big healthy trees that are just too dense that you end up, unfortunately, laying down. So that when we approach some of this work, we'd just like to run through some of the, the considerations that you think maybe some of this stuff would be. I guess when you're working through your own properties, your own sites, or you've got your own context in mind, these are some of the things that I'd be encouraging you to think about before considering you're undertaking any thinning. Safety is an obvious one, but when there are some contexts that are unsafe, we tend to just leave it. Like if there's denser areas and sparser areas, it doesn't matter. There's no need to bite off anything too extravagant. So the safety one's a big one. Desired final tree spacing. For the Spring Plains project, we had a retained basal area target that we were working to, but that will vary depending on site. Really important to consider your desirable final tree species ratios. So it's quite easy to chop down the trees that are easier to cut and leave the ones that are harder to cut. That's something that you'd certainly consider. If a tree is particularly hard on a chainsaw, you might choose to walk past it. But yeah, if you've got a ratio of 60-40 box to ironbark or whatever the ratios are, I think at the end of the project you should be considering trying to keep those ratios more or less the same, unless you've got a really good reason not to. I touched on that slightly, you know, how heterogeneous do you want it to be? Some areas we could actually thin quite aggressively, have them quite open, and then other areas we might leave quite dense, depends on the size of the patch that you're working in and what's in the matrix. So if you've got large open grassy areas adjoining your patch, it's probably not that critical that they're represented within the patch. But if you don't have that, or if it's a huge site and you want to establish some high levels of heterogeneity, then yeah, having some areas that are really quite sparse with trees, and then some other areas where you retain a really high density is probably going to maximise the number of species that you're able to support. Desirable log densities, yeah, so that's just touching on the fact that as you do lay these trees down, where you put them needs to be considered. You don't just want to drop them up and down the slope. You might want to put them across the slope to retain soil, retain leaf litter. So there's a few considerations that you need to be thinking about with that. A big one, particularly if you want to keep your neighbours on board, is bushfire planning. Laying down trees with canopies, you end up with elevated fine fuels. Pretty big issue. So yeah, I'll show some photos at the end of the slide. I've got a couple of photos. Yeah, just making sure all of that elevated fuel is on the forest floor. It'll actually do what we want it to as fine fuel, retain moisture and, you know, do all those good things that you get from leaf litter. But yeah, having branches elevated and creating ladder fuels for a fire might get into the canopy is a pretty big issue. Seasonality of treatment, yeah, that's more about if you've got species there that you're concerned about, avoiding nesting. Maintaining habitat hollows, that's all fairly straightforward. I think that's a no-brainer, but it's important just to mention it. I put in there that, you know, we're sort of trying to achieve canopy separation to allow the sunlight to get to the forest floor, and so we may actually be able to take, you know, a tree that's got some coppice stuff and keep one stem and take the two outside ones, or we might actually be able to thin an area without necessarily removing entire trees. That has a flow-on effect of allowing you to retain some genetics as well, so that you never know really what sort of a genetic base you're starting from. So yeah, if we can keep trees but actually minimise the footprint that they occupy, that's a really positive thing as well. Really keen on multi-year approaches. Start small, pick out the easy ones, you know, get rid of your ones that already look like they're dying, and then over 4 or 5 years sort of progress through taking on your more adventurous ones. And then you have got a note about communicating, because yeah, people are going to ask the question about what you're doing in your forests with your chainsaw. So this is the site at Spring Plains. So I think I've got 3 photos. They're all more or less the same, and it's hard to represent, you know, forests on, you know, I don't think the photos do the sites justice, but you can sort of see what we've tried to achieve here, and there's very little elevated fuels. So even though all of these trees had canopies, you just can't really see it, like there's not really prominent. And then yeah, some of them have been chopped up into manageable pieces so that we can run them across the contour. You can sort of see it's running down the hill into that swale behind the sort of, I guess, the mid-ground. Yeah, running those logs across that hill will slow the water down and allow it to infiltrate a little bit better. So yeah, as a part of a larger body of work of, you know, like the forest restoration work that we did with this project, the ripping and the earthworks, you can see how that will sort of assist with that. It would slow everything down and it would really help. That's just another photo. It's actually the same site, just from the other direction. Just an example of a bifurcation or a coppice at the bottom there. You know, that's something that you might take off. There's a tree at the other side that's got 2 halves. You might choose to take one of those. Just depends on what you're dealing with. And I think this is one more. Yeah, and you can sort of see here another good shot where all of the leaf litter, the canopy is all flat on the ground. So yeah, that's sort of, I guess, a general idea on what we're trying to achieve. You know, there's groups of ironbarks on the left there that have been retained. They're all good trees, so we left them. And then there are some other areas, you know, where we probably went a little bit heavier. Yeah, I think that's about it. And yeah, it looks like there's an ironbark there in the foreground that's probably not going to see. It's the one that's got the branching at the top, the co-dominant leaders. That's a tree that you might prioritise for removal, just because I don't think that tree is going to live to be 150. There's a photo of proof that we were there. And that's me. So, yeah, thank you.
Thanks, Daniel. Thanks, Paul. We're going to take 2 questions. We're going to try and do them as quickly as we possibly can because we're a little bit over schedule already. But also, if anyone's coming to the dinner, Daniel will be there. And if anyone's joining us on the site visits tomorrow, Daniel will also be there. So there's opportunities to speak at those 2. But if we have 2 quick questions, we can do those. Carl?
Yeah. Have you trialled coppicing in just a few select areas rather than poisoning the stump?
Sorry, should put that down. As a general rule, across the board, we poisoned all of the stumps. The theory being, I guess, that as the larger trees get bigger, the small coppices should get outcompeted anyway, if the site's just going to naturally thin. But yeah, no, I think as a practice, we'd prefer to poison the stump and actually make sure that they're gone, they're not going to come back. But yeah, there's certainly merit in a whole range of different approaches, but that was the one we went through here. And just this site lended itself to that kind of an approach. But yeah, look, there's other things we can try for sure.
There are some areas of the site that are actually naturally coppicing, even though they were poisoned. So yeah, there's going to be areas that are coppiced anyway.
First of all, congratulations. This looks already like a very successful project, despite you saying before that you need more data and more indicators to make this resonates. My name is Alex. I work for Pagnol Land and Water Council, and I have a question on whether could you reflect on the best way to outscale these sort of projects in water landscapes, and what sort of mechanisms, other than philanthropists and other citizen scientists who are contributing to that, how can we outscale these and make it financially viable? What sort of things are you thinking already, without telling us already which are going to be your strategies, because we may end up competing with you? But yeah, how can we pay for all these? Because we look forward to seeing more of these across the whole.
Yeah, look, thanks for the question. Basically that's the big issue. We feel like this is proof of concept, or it's starting to be, or it will be in due course, maybe with further adaptations. But yes, the big question for us is how do we scale it up? The cost of it overall, I don't have the figures in front of me, but it wasn't a particularly enormous budget. And I think that with efficiencies and improvements in techniques and so on, you could get the costs down. I think that partnerships with other organisations, philanthropists, which has simulated this pilot so far, could help with that process. Maybe some of the emerging sort of nature positive type markets could help in that regard too, and maybe collaborations even with Indigenous groups like yourself, if you're interested in that sort of thing, that might help to sort of scale up these areas into bigger other landscapes where currently it's not happening. And then there's of course private land, and private landholders can potentially support this as well. So I think it's a combination of things, and it will be a necessarily sort of scattered scaling up, but I think it's really necessary to do it. I think that if we can do it, we can potentially get some big benefits for the landscape in general and for many of the threatened species that are still just hanging on in those areas. Thanks for the question.
Thanks, Paul. Thanks, Daniel.